Okay, now we move to a new lesson, sampling methods and the central limit theorem. Of course, in this chapter, we're going to talk about important concepts, namely about sampling. So in this chapter, we study sampling. What actually do we mean by sampling? Sampling is a tool to conclude something about a population. You know, the population is sometimes infinite, it's big, it's very large. So we have to focus upon a sample, a portion of the population. So in many cases, sampling is more feasible than studying the whole population. You know, to study the sample is, has lots of benefits. Is much feasible than studying the whole population. So let's look at the reasons for sampling. Why do we sample? Why statisticians usually sample? Usually focus upon a portion of the population rather than focusing upon the whole population. So the major reasons for sampling, the first reason is that the contact of the whole population would be time consuming. It would take lots of time. Let me give you an example. Let's say a candidate is running for a national office, and he would like to know about his chances for election. So usually a professional polling firm would take, let's say, 1 day to contact 1,000 individuals, 1,000 to contact 1,000 individuals. Let's focus upon a country, one country. Let's take, for instance, the United States. In the United States, there are over 250 million individuals who are allowed to vote. So, a professional polling firm, it would take it about 1 day to contact 1,000 individuals to, get their responses, to see about the chances of that candidate. If 1,000 individuals would take a professional polling firm 1 day to contact them, imagine how long time it would take the firm to contact 250 million people. If 1,000 individuals would take 1 day, 250 million, talking about the United States, where there are about 250 million individuals who are allowed to vote. To contact all those 250 million people, how long time it would take that firm? 250 million would take, how many days? So just a cross multiplication, we come up with, 250 million over 1,000. So we come up with what? 250,000 days. So it would take 250,000 days to contact 250 million people in the United States. We can know how many years it would take them. We just divide this number over 365 because 1 year is equivalent to 365 days. So we divide this one over 365 days to see how many years. Let's look at here. 250,000 divided by 365, we come up with 684 years. 684.9 years. Imagine to contact the whole voting population in the United States, it would take 684 years, about 685 years. That's why we say the contact of the whole population would be time consuming. Therefore, we just focus upon a sample rather than the population. Okay. We move to the second reason for sampling. Why, statisticians usually sample. Why do we sample? The second reason, the cost of studying all the items in a population may be exorbitant, may be very excessive, very expensive, very costly. Let's give an example. There are many consumer testing organizations in the United States, such as the Harris Internationals or CBS News polls. Let's say many companies sometimes they would like to know about their products. Let's say a company that wants to know about their newly produced good, such as breakfast cereal or perfume or cat food or whatever. So what they do, they hire a consumer testing organization to contact families in the United States to see their responses about the product. So let's say any consumer testing organization in the United States, at least they charge $1,000 to contact 1,000 families. 1,000 families, to contact 1,000 families to get their responses, to tabulate their responses in order to test the product. It will cost, let's say, $1,000. I'm very sure it costs more than that. Let's, take the minimum. It costs $1,000 to contact 1,000 families in the United States. Remember, in the United States, there are over 60 million families. If 1,000 families cost $1,000, 60 million families, how much it costs? To see that the cost of studying the whole population is very costly, very expensive. That's just a matter of cross multiplication to see that. Okay, so x here is equal 60 over 1,000. So we'll come up with 60 $60 million. So $60 million. If we assume that the consumer testing organization only charges $1,000, but I'm very sure it charges more than that. So if it charges $1,000 to contact 1,000 families, imagine how much it costs to contact the 60 million families in the United States. It costs $60 million. You see that the cost of studying all the items in the population may be very exorbitant, very excessive, and very costly. Of course, another reason for sampling, the physical impossibility of checking all items in the population. That some populations are unlimited, are infinite. Take, for instance, water. Let's say we want to test the bacterial level in water in the Mediterranean. So it's impossible to check all the water for bacterial level. So what we do, we take samples of the water. Let's say if we're talking about the Mediterranean Sea or the Al-Kalb River or Al-Asi River or Al-Awali River. So in order to test the water for bacterial level, we just take water in some locations in that river or in the Mediterranean. Okay. Same thing goes with the population of fish or mosquitoes or birds. The population of these are infinite. The population of these are infinite or unlimited, and they are constantly moving. Therefore, for instance, to have an estimate of the fish in the Mediterranean or in some lake, you can't, check or count all the fish in the Mediterranean, suppose, or in a certain lake. You have to have an estimate by using certain techniques, such as setting nets at predetermined locations in the lake or in the river or in the Mediterranean. Okay, or for instance, get a certain or count the fish in a certain location in the river or in the lake. Why? Because the population of these creatures is very infinite. Therefore, we have to do like this. The same thing goes with the destructive nature of some tests. This is another, reason for sampling. The destructive nature of some tests. Actually, what we mean here is that if we take the area of industrial production, the production of, steel plates or wires, these products, of course, must meet certain minimum standards, must have a minimum tensile strength. Therefore, to test or to meet the minimum standard, they select samples of wires, and so what they do, they stretch each wire until it breaks, and the breaking point of the wire is measured in, let's say, in kilogram per centimeter square or in pounds per inch square. Okay? Now, the question is, if all the wires were tested, to see whether they meet the minimum standards of tensile strength or not, then there would be none available for sale. That's why we have to use a sample of wires, because we can't use the population of all, wires or plates and so on and so forth. Same thing goes with the fifth reason of sampling, for sampling, is that the sample results are usually satisfactory, very adequate. Why is that? Let's say, take for instance, in each country, the government usually present each month a monthly index of food prices. And that index consists of the prices of foods such as milk, bread, eggs, and so on and so forth. So, usually in order to present this index of food prices, the government selects a sample of grocery stores from all the grocery stores that are spread all over the country. They usually selects a sample of the grocery stores. And this sample is satisfactory. Why? Because the prices of food, such as the prices of milk or bread or eggs, usually differ by, by 1 or 2 cents from one store to another store. The prices of food, the prices of foods, such as the prices of milk, the eggs, bread, differ by 1 or 2 cents. They don't differ by more than 1 or 2 cents from one store to another. Therefore, getting a sample of grocery stores would give, satisfactory results of the monthly food index. Okay, now we move to talk about, methods of finding samples or selecting or choosing samples. Of course, statisticians here talk about, four methods of selecting samples. To obtain samples that are unbiased, statisticians use four basic methods of sampling. The first method is simple random sample. In this method, a sample selected so that each item in the population has the same chance of being included. Therefore, in this method, samples are selected by either using chance methods or random numbers. Let's talk about chance methods. Chance methods. Let's say, for instance, we have 1,000 employees, and we are to choose a sample of 100 employees. So what we do, we write the name of each employee in a small piece of paper or small slip of paper, and then place all the slips that include the names of the employees in a box, and then mix that box thoroughly, and then select as many slips as you need. Suppose we want to select a sample of 100 employees, so we select 100 slips from this box, and the names of the slips, the names whose slips were selected, of course, constitute the sample we are after. Now, sometimes it is difficult to obtain an unbiased sample. Why? Because perhaps we did not mix the slips thoroughly. As a result of not being mixed thoroughly, you, of course, get a sample that is not unbiased. So a statistician use an alternative method of getting random samples. That method is, of course, which is called random numbers method. Usually, random numbers, such as the random numbers, the two-digit random numbers you see here, are usually generated by computer or by a calculator. So, suppose here we have a two-digit random numbers. And suppose you want to choose, 20 subjects out of 90 subjects. So here, random number method. So we want to choose 20 subjects. Choosing 20 subjects out of 90. Okay? So what you do, it's necessary first to number the 90 subject from 0, number the subject from 0 till 90. So we have 90 from 0 to 90. Then we want to choose the starting number. So what we do, we close our eyes and then place our finger on any number in the table, okay? And where our finger is landed, this is the first number or the starting number. Suppose our finger is landed on this number 14. is landing on the number 14. Okay, then what you do, we just proceed, counting the numbers, 20 numbers. Make sure, first of all, your number landed here, then you move to count, you move downward in this column here, all the way until you reach the bottom. If you did not, still you need more numbers, then you move to the top of the next column until you select 20 numbers. Make sure in the process of selecting 20 numbers that if you came across a number that is greater than 90 or a duplicate number or 0, then you neglect them. So a duplicate number or 0 or a number greater than 90 are neglected, are omitted. Okay? Now let's say we start 14. 14 is a starting number. We move down 31, 43, 21, 17, 83, 93 is above 90, it's neglected. 96 is above 90, is also neglected. 74, 84, 14, or we got 14 here, so it's neglected because it's a duplicate. 29, that's 29. 11, that's 11. 05 is also selected. 03 is selected. Then we reach the bottom, then we move up to the top of the next column, which is 60. 15, we got 15 here, don't have 15, we just write it down. 32, we don't have 32 over here, write it down. 24, we don't have it 24 over here. Let me count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We still need 4 more numbers. 24, 12, we don't have 12 here. 33, we don't have 33 here. 18, we don't have 18 over here. And 44. So now we chose 20 subjects, okay, out of 90 subjects. And these are the subjects we're looking for. This is the random number method, okay? This is the alternative method that is used by a statistician to select random samples. Now we move to the second method of getting a random sample. Now remember, in the previous method, which is a simple random sampling, here remember that in the previous method, the simple random sample method, it requires the numbering of each subject before using the random number table. Remember, in the simple random sampling, we have a random number table. And so that process requires the numbering of each subject before using the random number table. And therefore, this numbering process could be time-consuming job. Okay, therefore, the alternative to that method is the systematic random sample. What is systematic random sample? It is, in this method, of course, a random starting point is selected. And then every kit number of the population is selected. Let me explain this. First of all, we need to find the kit number. That suppose, now first, calculate the kit number. The kit number is obtained or calculated by dividing the size of the population by the size of the sample. Suppose, the population is 1,000. Population 1,000. And the sample we are after to select is, or the sample size is 100. Sample size is 100. So the kit number is calculated by dividing the population size by the sample size. So now the kit, of course, kit is equal population size over sample size. And we come up with what? 1,000 over 100, which is equal to 10. So now the kit number is equal to 10. Great. Now, we need to first, select the starting point. So the starting point of selecting 100, employee or 100, the size of the sample, which is 100, from 1,000 individuals, the starting point is a number between 1 and 10. The kit is equal to 10. So the starting number, is the first number, is any number between 1 and 10. Let's say 5. Let's say 5. So first number is 5. Then what the second number? We add 1, we add 10 of it. We add the kit. So the second number, 5 plus 5 plus 10. The third number become about 15. Now 15 plus 10, that's the third number. So we get here 25. Then 25 plus 10, we come up 35. Then 35 plus 10, we get 45. Okay? So 35 plus 10, we get 45. So the one, first, second, third, fourth, fifth. Now here 45 plus 10, and so on and so forth, until you assemble 100 number. Okay, until you assemble 100 number, which is the sample size. So you continue with this process. You just add 10 to each number. 5 plus 10, 15. 15 plus 10, 25. 25 plus 10, 35. 35 plus 10, 45. 45 plus 10, this is a number. So we have 5, 15, 25, 35, 45, 55, 65, 75, and so on and so forth until you obtain 100 numbers. And this is the systematic, random sample method. Okay, the third method of getting a sample, an unbiased sample, is through a stratified random sample. What actually do we mean when we say stratified random sample? Here in this method, the population is divided into subgroups. These subgroups are called strata. And a sample is randomly selected from each strata, from each subgroup. Let me give you an example. Say the mayor of a certain town would like to know how people living in that town feel about a certain economic issue. Suppose that the town is divided into 3 neighborhoods, and each neighborhood is populated by a different sect. Suppose we have 3 sects. We have Christians, Muslim, and Jews. 3 neighborhoods are populated. Each one is populated by a different religious group. So, furthermore, the president or the mayor of the town would like to know the opinions, how the opinions of each neighborhood, of the people of each neighborhood, differ from the opinions of the other neighborhoods. So what he does, he takes, from each neighborhood, he selects some people from each neighborhood and then to constitute a sample. So the sample will basically consist of people from each subgroup or from each strata. Okay, he selects people from the neighborhood that is populated by the Jews. Also, he selects some people from the neighborhood that is populated by the Christians. Also, he selects some people that is populated from the other neighborhood that's populated by the Muslims. So, those people selected from the three neighborhoods will constitute the sample, okay? And that sample should be unbiased. Okay, now we move to the fourth method of sampling, which is called cluster sample. Cluster sample. In this method, the population is divided into groups. These groups are called clusters by some means, such as geographic area or schools in a large school district, etc. Then the researcher randomly selects some of these clusters, some of these groups, and use all members of the selected clusters or groups as the subject of the samples. Cluster sampling is used when the population is large and when it involves subjects residing in a large geographic area. For instance, let's say somebody would like to have a study involving patients in Beirut City, patients in hospitals in Beirut cities. Now, Beirut is a very big area, very large geographic area. So it would be very costly and time-consuming if that researcher selects a sample of patients from these hospitals, because hospitals are, located in a very large area, and patients are spread in so many hospitals. Therefore, it could be time-consuming and costly to have a sample of patients. Instead, the less costly type of sample is to select a sample of hospitals and then select a sample of hospitals and interviews the patients in these hospitals. That way, he could have an easy way of, getting the information about what he is after to get. So, in cluster sample, instead of having a sample of patients, talking about here, a study that, about a study about patients in Beirut City. So the best way to have that study give you an efficient results is to select a few hospitals and interviews the patients in these hospitals, rather than selecting a sample of patients from all those hospitals. So this is what actually we mean when we say cluster sample. So this is the fourth method of sampling. It's cluster samples.